All right, so last class we looked at solving rational equations, and today what we're going to do is take the next step and solve rational inequalities. And so the first two examples, what we're going to look at is graphically, visually, what are we actually looking at? And so in our first example here, it says find when the function or the graph x minus 7 divided by x plus 2 is greater than 3. Now, the greater than 3 is just saying a height of 3, which I've drawn in here as a red line. The function that we have here of x minus 7 divided by x plus 2 is what I've got drawn in purple. And what you'll notice is that tying into what we've been doing with in terms of our vertical asymptotes is that this function does have a vertical asymptote at x equals -2. But essentially, graphically, what we're looking at here is when is the function in purple greater than the function in red. And so what I look at here is that this point here, and I'm not sure if you can see it, but this is a -6 here, is that at -6, this graph goes higher than our red line, but then again stops at that vertical asymptote of -2. And so if I was looking at one of the intervals in which this inequality is true, I would say from -6, but not including, all the way to -2, but not including, because again, there's a vertical asymptote. If I'm looking for other intervals in which this purple graph, I guess, is greater than our red line, there isn't any. From here on in, this graph is lower than our horizontal asymptote of 3, I guess, if you will, or our height of 3. So the final answer here is on the interval from -6 to -2 is when this purple graph is higher than our red line of 3. Now, in example 2 over here, we've got two functions. In red, I have my simple y equals x linear equation, which is just drawn again as a line of a y-intercept of 0 and a slope of 1. On the other, again, is our function, a rational function of 3 divided by x minus 2, which again, I've roughly drawn in purple over there. Now, again, you can see that there is a vertical asymptote here of 2. But what our equation or our inequality is asking is when is the red line underneath the purple graph? All right, so I look, when is the red line underneath the purple graph? Well, over in the left-hand section here, this purple graph is, this red line, which is our x value, is under the purple graph from all the way from infinity. And then on my graph, it's all the way to, that's a -1 right there, so all the way to -1 is the interval in which our red line, which is the x, is less than our purple graph. Now I keep going to see if there's other intervals. In our first example, there wasn't any more. Maybe there is on our second example. And so again, I look, when is our red line, y equals x, underneath our purple line? Well, again, there is a vertical asymptote here at 2. And so, but it is underneath, this red line is underneath our purple graph for a little bit. And I would say from about 2 to 3. And again, it can't be inclusive of 2 because that is where our vertical asymptote actually is. So it can't be 2 right on. But from about 2 to 3 that I see on the graph, yeah, that red line is underneath our purple graph. So again, that is graphically what solving a rational inequality looks like. Now what we're going to go get into is how do we solve these things algebraically? In other words, when we have an equation. All right, so we get to example 3, where we have, let's see here, put example 3, where we're going to solve the inequality x squared minus 4x plus 4, let's see here, divided by x minus 4. And I want to know when that rational equation here is less than just 2. All right, so here's what we've got. Now, the first thing that we look for when we're dealing with rational equations, and we should have looked at this when solving rational equations, not just inequalities, is that when is the graph where do we have a vertical asymptote? Because at a vertical asymptote, something special is happening there. And that's what we're looking for. When does something special happen? Now, in this case, in our denominator here, this graph has a vertical asymptote. And so one of our restrictions, I guess you could say, or one of our special points is that, first of all, x cannot equal 4 for this equation because you cannot divide by 0. And so what we say is, therefore, x equals 4 is what we call a critical number. Now, that's going to come in later on why we need that number. But it's going to be one of our critical numbers because, again, there's a vertical asymptote there. And so something happens there. Just like when you saw our graphs in our example 1 and 2, we had vertical asymptotes. Things changed really quick at those vertical asymptotes. Now, the next thing is we want to find out when this inequality could be true. And now here's the issue is that we can't just cross multiply like we did when we are solving rational equations, because we don't know when this thing is positive or negative. And if you recall, when we were solving rational equations or just inequalities in general in our last unit, when you divide by a negative number, you flip the sign. And so we don't know whether this is positive or negative, and so we can't just cross multiply because that would change our sign. So what we do have to do is change this inequality so that we have a 0 on one side of the equation. And so I'm going to now write this equation out where we have x squared minus 4x plus 4 all over x minus 4. I bring this 2 over, it's going to be just a simple minus 2 is less than 0. Now, this is something that we looked at last day, is combining these two terms. And the only way to do that is if they have a common denominator. Now, this 2, as I've written up here, does have a common denominator, or has a 1 as a denominator. But I want them to have a common denominator so I can put these two terms together. And so what I can do is multiply this 2 on the top and the bottom by x minus 4. Now I do the top and the bottom so that essentially I am not changing that term. I'm just changing the way it looks because, again, x minus 4 divided by x minus 4, they would cancel each other out. But I want them to stay there because, again, I want a common denominator. So now we have a common denominator of x minus 4. And now on one part here, I have an x squared minus 4x plus 4. But then I have all this other stuff. Now I have this minus sign. I got to watch out for that. And so what I can do is the rainbow rule to see what the leftover is. So I got minus 2 times x. I'd have a minus 2x. And then I have a minus 2 times this minus 4 here, which give me a positive 8. And again, that is less than 0. So now I have one term here, all right, to see this inequality. Now I'm going to collect like terms because I have x's and numbers that I can put together. All right, so I end up with now x squared minus, minus 4x minus 2x. That's a minus 6x. Put that in there. And I got a 4 and an 8 together, so that's a positive 12. All over x minus 4. It is less than 0. All right, now, here's what in the end I'm trying to do here. I'm trying to find out, to solve this inequality, when the bottom is equal to 0, which I already did. That's where I got my critical number. And when the numerator is equal to 0. Now, to do that, I'm going to have to solve this quadratic that's on the top, this x squared minus 6x plus 12. All right, so I'm going to factor it. Let's see here. I don't want to run out of room. But again, I'm going to put my first term in the top left and my last term in the top right. All right, and let's see here. We have x and x. 12. I don't know if I can crisscross. And guess what? I'm going to cheat a little bit and tell you that I can't factor this. All right, so here's what I'm going to do then. I'm going to try the quadratic formula. for this quadratic. All right, which again, I have x equals, whoops, get that messy. X equals my minus b. Let's see, minus b is minus already, so it's going to become a positive, plus or minus the square root of b squared. Again, b is -6, the number in front of x, so that's -6 squared. Minus 4ac, what's our a here? Oh, it's 1. And c is 12, so 1 times 12. All over 2a, which is 2 times 1. All right, so again, it's trying to solve this quadratic to see when our numerator could possibly be 0. All right, so I get x is equal to 6 plus or minus, let's see here, 36 is -6 squared, minus 4 times 1 times 12. Minus 4 times 1 is minus 4 times 12 is a minus 48. All over 2. Now, when I look at this quadratic equation, I got a 36 minus 48 underneath the square root sign. That means that answer is going to be negative. And what I can't do is I can't take the square root of a negative number. And so, in fact, there is no solution to this problem. All right. So here's where we're at to solve this inequality. I've got this simplified version, as simple as it's going to get. And so I'm going to now do my number line. But I've only got one number to worry about, the x equals 4. All right, so what I want to look at is my intervals. And there's a VA there. And so all I'm going to look at is on my interval here, do I have a positive or negative value? And so a number left of 4, I would put, say, a 3 in there. A 3 in the bottom. Well, 3 minus 4 is negative. But I also have to worry about the top here. So I put in a 3 here. So 3 squared is 9. Minus 6 times, that's minus 18. Plus 12. That's actually going to be positive when I put a 3 into this top polynomial. Rub that out, so that's a positive. So on this interval, a positive divided by a negative. Negative. Well, that satisfies our inequality. And let's see here. Now, a number right of 4, like a 5. Well, on the bottom here, plus. Let's see here, 5 squared is 25, minus 6 times 5, which is a minus 30, plus a 12. So something like that would be, looks like positive. There we go. So now I've done my intervals. I can finally write out what my the solution is for my inequality. And so therefore, f of x, the function we're worried about, is less than, what was it, 2 on the interval let's see here, well, all the way from left of 4 all the way up to 4, but not including 4 because there's a vertical asymptote there. And so on the interval -infinity all the way to 4, not inclusive again because there's a vertical asymptote there. All right, so again, we had to move it over to one side, get them as one term, then figure out when is your denominator equal to 0 and when is your numerator equal to 0. And those are the numbers that we're going to use on our number line to figure out the intervals. All right, so let's try one a little bit harder than that. So let's see here. Put that back. Gonna have to do a little bit of cleanup here. All right, so example number, let's see, what are we on here? Number 4, 2 more, eh? All right, so this time, what do we got here? Solve the inequality We've got to wipe that down a little bit more. All right, so let's see here. Solve the inequalities is example number 4, where we have x squared plus 2x minus 8 all over x minus 2 is greater than 0. All right, so the first thing here is we already got one term on one side of our equation. Perfect. We got a 0 on the other. So now I'm already fast forwarding to the part where I'm just looking at when does the numerator equal 0 and when does this denominator equal 0. All right, now first off, VA, when does the denominator equal 0? X equals 2 is what we call a critical number. It just means something special happens there. In other words, in this case, it's a vertical asymptote. All right, now I also need to look at when does my numerator equal 0. And so again, I have a quadratic there and I'm going to factor it. I'm going to try anyways. So we'll see what happens. All right, so again, let's see. First term up in the top left, x squared. Last term in the top right, a minus 8. Let's see here, x and x for x squared always. Negative 8. And then I got to cross multiply and get a 2x. So let's see here. Oh, I think I know this one. I'm going to go with a 4 and a minus 2. And so when I cross multiply again, I got 4x minus 2x. And that again will give me the middle here of 2x. So I can factor the top this time. I don't have to use that quadratic formula. And so I can change my numerator now to x plus 4 and x minus 2. All over x minus 2 is less than 0. All right, now, a couple of things with this example. This y or x equals 2. You see how it makes the numerator and the denominator 0 at the same time. That means there isn't a vertical asymptote there. There's actually a hole there when that happens. When you have a value that makes both the numerator and the denominator equal 0 at the same time, you got a hole, not an asymptote. So that's what that's telling me. Again, that's why it's called just a critical number, not where the asymptotes are. Well, I also have another value here. X equals negative 4 will be another number that we're going to use because it makes the top equal to 0. All right, so now I've figured out all the values in which both the numerator and the denominator can be equal to 0, and so I get to my number line. All right, so put an arrow there and an arrow there. All right, so what numbers do we have here? 2 and negative 4. So again, negative 4, our function equals 0 there. And at 2, x equals 2, we have a hole there. All right, so we're going to have to check out 1, 2, 3 different intervals, all right, to see where our function or our inequality is true. So we'll start off with a number left of negative 4. So let's see here. I'll put a negative 5 in here. It's going to be bottom. Be negative. Negative 5 here makes that negative. And a negative 5 here makes that negative. All right, well, a negative times a negative is a positive. Then divided by a negative gives me a negative. Okay. Then I need a number between negative 4 and 2. Well, I always go with 0 when I can. It's easiest. Put a 0 in the bottom. It's negative. Put a 0 here, it's positive. Put a 0 here, it's negative. So I'm going to have then a positive and then a negative. And so again, figuring out, well, a positive times a negative divided by a negative. Our value is going to be positive in that interval. All right, now we go after 2. So a number like 3, of course. So our bottom there is definitely going to be positive. 3 minus 2 is positive. 3 plus 4 is positive. And 3 minus 2 is positive. Okay. And so what we're looking at is positive times a positive divided by a positive is positive. So what makes our inequality true? Well, therefore, f of x, I'm just going to say the function is greater than 0 on the intervals, I should say, plural. Well, first off, from -4 to 2. So we can write that a bunch of different ways. -4 is less than x is less than 2. And after 2. Again, not at 2 because there is a hole there. All right, so at x is greater than 2. So again, there is 2 intervals in which that is true. All right. Any questions so far? Before we get to the granddaddy, the last one here. All right, gonna give it a flip. All right, so let's see here, just a little cleanup here. For example 3. All right, so last example, number 5. So let's see here. We have find the inequality, which makes, this is where we have 2 functions. So example 5, where we're looking at the function 2x plus 1 divided by 2x minus 3. I want to know when that function is greater than another rational function, which is x plus 1 divided by x minus 5. All right, there we go. Now, the first thing is that we have 2 denominators here. We have 2 spots where there's vertical asymptotes. Well, I think anyways. Well, for sure here in x minus 5, because a 5 does not make both the numerator and denominator 0. So x equals 5 is a critical number. And then we also have a denominator here. So if I solve that, 2x minus 3 equals 0, 2x equals 3. It looks like x equals 3 halves will be another critical number. All right, so we've already out of the gate got 2 numbers that are going to be on our number line, 5 and 3 over 2, because both of these rational functions have asymptotes. So something happens there before and after. Now we have to solve the rest of this inequality. And so I need, again, a 0 on one side of the equation. So I'm going to, I guess, drag this one over. So that I'm going to end up with, let's see here, I want to make this messy. So let's get rid of this solving. We're getting 3 over 2. All right, so I got my 2x plus 1 all over 2x minus 3. I'm bringing this inequality or this rational function over, so it's a minus, changing sides, changes signs. So I have an x plus 1 divided by an x minus 5 is greater than 0 now. All right, now to actually solve this inequality, again, I have to combine my 2 functions. And the only way to do that is having a common denominator. And so what I can do is when I have these 2 denominators, I got an x minus 5 and a 2x minus 3. And so my common denominator is actually going to be 2x minus 3 times x minus 5. Now, to make that happen, I'm going to have to take my first function and multiply it by x minus 5 on the top and an x minus 5 on the bottom. My second rational function, I'm going to have to multiply both the top and the bottom by a 2x minus 3. That's the only way I can get them a common denominator. Now, here's what my numerator now looks like. I have this 2x plus 1 times my x minus 5, subtract this part here where the x plus 1 times the 2x minus 3. This one's going to get a lot messier than what we had before. Is greater than 0. All right, so again, when we're looking for numbers to put on our number line to find our intervals, we have to look at when the numerator or the denominator is equal to 0, which we already did right off the bat. But now we have to figure out when the numerator is equal to 0. So I'm going to have to do FOIL twice and then collect like terms and then see what I got, because then I'm going to have to solve it. All right, so again, using FOIL here. All right, so again, there's my common denominator. All right, so let's see here. 2x times x, 2x squared. 2x times a negative 5 is a minus 10x. 1 times x is an x. And then 1 times a minus 5 is a minus 5. All right, so there's the first FOIL done. Now, the key to the second FOIL, and this is where a lot of people make mistakes, is I got a minus sign. So every time I do FOIL, I'm going to times it by negative 1. So when I have x times 2x, which is 2x squared, it's going to be a minus 2x squared. X times a negative 3x is negative 3x, but a minus sign gives me a positive 3x. Then I have a 1 times 2x, but then times a minus sign is a minus 2x. And then lastly, 1 times a negative 3 is a minus 3, but again times a minus sign is a plus 3. Is greater than 0. Woo! All right, so I got to collect all these like terms. All right, so here we go up here. Greater than 0. Again, we have our two denominators, 2x minus 3. And we also have, what's our other one? X minus 5. All right, now to collect what we got up top. All right, so the x squared's first. 2x squared minus 2x squared. Cancel each other out. Perfect. It's not going to be a quadratic equation we're solving here. All right, but then I got a minus 10x plus an x, so I'm minus 9x. Plus 3x, so now I'm minus 6x. Then minus 2x, so that's a minus 8x. I want to put all the x's together. What about the numbers now? Let's see here. Make sure you don't miss any, right? I got a minus 5 and a plus 3. That's a minus 2. There we go. So that big numerator shrunk down to minus 8x minus 2. I would actually challenge you to try that out just by yourself. Try example 5 if you get the blank copy and see if you can get that simplified like that. But again, when I'm looking for my numbers for my number line to check the intervals, I got to see when the numerator is equal to 0. And so I'm going to solve here. When does minus 8x minus 2 equals 0? Well, let's see. I'm going to move that minus 2 over to the other side. So it's a positive, minus 8x equals 2. Divide both sides by negative 8. And it looks like x is going to be 2 over 8 is, or negative 2 over 8 is negative 1 over 4. Or negative 0.5, however you want to look at it. Just as 3 over 2 here, I could write as a decimal as 1.5. Whether you write it down as a fraction or a decimal, it doesn't matter because they're the same number. They just look different. All right, so now I'm ready to do my number line. I've got my two critical numbers off the bat, which told me when the denominators are equal to 0. And then after doing a lot of work here, I figured out when my numerator could equal 0. So here we go on my number line. All right, so what numbers we got here? 5, 1.5, and negative a quarter. All right, so there's negative 1/4. I get a 0 there. Let's see here. Then I got a 3/2. So I'll put that right here. We have a VA there, vertical asymptote there, and then 5. Where I also have a vertical asymptote going on there. So I'm going to have to check out 1, 2, 3, 4 different intervals to see when this inequality is true. All right, so let's start off with a number left of -1/4. I'm going to go with -1. And so let's see here. 2 times -1 in the bottom there is -4 minus 3. That's definitely negative. -1 minus 5, that's negative. And what about the top? Put a -1 in there. For -8 times -1 would be positive 8 minus 2, positive. All right, well, that looks like it's going to be positive before -1/4. All right, next up, a number between -1/4 and 3/2. So the best one is 0. Put a 0 in here, that's a negative. Put a 0 in there, that's a negative. And put a 0 in our numerator, that's a negative. So in this particular interval, it looks like our values will be negative. All right, then a number between 3/2, which is 1.5 again, and 5. So I'll go with 2. 2 times 2 minus 3, that's going to be positive. 2 minus 5 is negative. And then what about our numerator there? -8 times 2 is a huge negative number. Minus 2 is definitely a negative number. And so let's see here. Negative divided by negative is a positive. And then, yeah, we're definitely going to have a positive interval here. Okay. Last interval. Let's see here. After 5, so we'll go with 6. 2 times 6 is 12 minus 3. Well, that's going to be positive. 6 minus 5 would be positive. And what about the top? -8 times 6, that's like -48 minus 2. That's definitely negative. And so a negative divided by 2 positives is going to be negative. All right, so in this case, we've got our number line down. So therefore, we got 2 functions here. I'll call one f of x and one g of x. And so therefore, f of x is greater than g of x on the intervals all right, so when is this greater than 0? Before -1/4. So x is less than -1/4. And what else do we have here? Between 3/2 and 5. So 3/2 less than x is less than 5. And there we go. So in this last example, not only did we get numbers for our number line given the critical numbers of when the denominator equals 0, but we also got one other number from when we made the numerator equal to 0. All right, so again, you have to have a 0 on one side and eventually work your way to the point where you only have one term simplified on the other side.